Hi there everybody, I hope you're doing well. This little video here will deal with the very important topic of squaring a binomial, which is an essential skill for all algebra students. Just so that everybody's clear what we're talking about here, a binomial is anything in the form a plus b, like maybe with parentheses usually around it, and if we are squaring that binomial, this is what we're talking about. It could be a minus b also, so I'll just shortcut there and say a plus or minus b squared. All right, this is what it looks like, folks. When you have a plus b squared, that always equals a squared plus 2ab plus b squared. All right, it always equals that. If you had a minus b squared, well, that's just a squared minus 2ab plus b squared. All right, the important thing that I want to stress right at the front here is that these forms should be memorized. You should memorize these things, folks. You'll get so much mileage out of them if you do. Please take a little trouble to memorize these things here. Memorize, memorize, memorize. It's so worth your efforts to do that. Let's look and explore here a little bit why the binomial squared looks the way it looks. Okay, well, if you took a binomial like a plus b and you squared it, of course you realize that that is a plus b times a plus b. Right? That's what squaring something means. Multiply it times itself. Well, you may recall a little trick about multiplying binomials together called FOIL, and if you're familiar with that acronym, fine. If not, it doesn't really matter. Whatever way you are familiar with using, you'll get the same thing. So, but if you are going to multiply those two things together, the first thing you would do probably is go a times a, and that's a squared. The next thing you might do is a times b, the first one times the last one. Sometimes we call those outer numbers. That's where the O in FOIL comes from. But anyway, a times b is ab, and then you would probably go b times a, which is also ab, and then finally b times b, which is b squared. Well, look, right there, that ab plus ab, that's where you get your 2ab. So when you multiply it all out, you get the a squared plus 2ab plus b squared. So that's it. That's how the structure gets that way from squaring a binomial. And just to make the point earlier, if it was a minus b, then that would be a minus b times a minus b, and you'd have a minus ab and a minus ab from doing that little multiplication, which of course would make your 2ab negative, and so the structure then would just be a squared minus 2ab plus b squared. So that's why I was saying earlier that it sometimes is convenient to think of a plus or minus b squared, and just in that same exact structure right there, a squared plus or minus 2ab, depending on what's in the binomial, and then b squared is always positive. Okay, so that's how that structure gets to look like it does, and so I thought I'd show you just a few more examples. These are some fairly common algebraic ones here. X plus 1 squared, that gives you x squared plus 2x plus 1. You know, think about that for a second. You got that 2x times it's 2 times x times 1. 2 times x times 1 is 2x. Let's do another one. X minus 5 squared. X squared minus 10x plus 25. That minus 10x there, that's 2 times x times negative 5. So that's negative 10x. Here's another one. 2x plus 7 squared. Okay, you get that one. Here's another one, another couple of them there. Look at these things. Just make sure that you can see how squaring one of those binomials on the left side gives you all of that expanded stuff on the right. So, pause the video if you want and stop it right here and make sure that you understand how we got each of those terms in the expansion. Now, just kind of a parenthetical little thought here, this rule, this structure of a binomial squared, it applies to things that aren't really technically numbers. Like you can take a couple of functions like sine theta plus cosine theta, square that binomial, you get the same thing, sine squared plus 2 sine theta cosine theta plus cosine squared theta, which simplifies a little bit because of a special trigonometric identity about sine squared and cosine squared, and it would simplify down to 1 plus 2 sine theta cosine theta. So you don't even have to know that right now. I just wanted to demonstrate something a little bit more abstract, perhaps, that the structure of a binomial squared always gives you the same thing. Let's look at some other examples here. These will mostly be irrational numbers. There's an irrational binomial there, 5 plus square root of 3 squared. Well, there's 25 from 5 squared, 10 root 3, that's 2 times 5 times root 3. That's 10 root 3. And then root 3 squared is 3. So you'd simplify that to 28 plus 10 root 3. So there you go. Look at that. You got to do that kind of stuff sometimes in simplifying fractions. Here's another one. 2 root 5 minus 1 squared. Okay, that gives you 20 minus 4 root 5 plus 1, or 21 minus 4 root 5. Think about how you got that 20 from 2 root 5 squared. Stop and think about that for a second. Make sure that you understand what happened right there. And then the minus 4 root 5. Make sure that these do not just float past your eyeballs and that you understand everything that's on the screen in front of you right there. Here's another one. What about a fractional exponent? Well, no difference, folks. When you square something with fractional exponents, you do the same thing. X to the 1/2 squared is just x. Then you have this 2 times x to the 1/2 times y to the 1/2. And y to the 1/2 squared is just y. You might leave it like that, or you might write it as x plus y plus 2 root xy. Those are the same thing, not saying that one is better than the other. So they're both the same thing. Here's another one. Square root of x minus 2 squared. That binomial squared is going to give you x minus 4 root x plus 4. Folks, the structure is the same no matter what the things are in the binomial, and it's always in this form here. A plus or minus b squared always equals a squared, and then plus or minus, depending on what's inside the binomial, and then 2ab, and then plus b squared. That's always positive, folks. The structure is the same, always, always, always the same. So please memorize this form, okay? So you'll be much happier if you do, I promise. Now go do some math and be well.